Welcome back to lesson 4.9, Algebra 2. We're going to solve a quadratic inequality in one variable. So we need to write the quadratic inequality so that the quadratic's on the left and zero's on the right. Then we want to factor the quadratic to find the zeros, and we're going to make a number line and place the zeros on the number line, and we're going to use a closed dot for less than or equal to or greater than or equal to, and we're going to use an open dot for less than or greater than. You're going to pick a value in each region of the number line created by the endpoints at the zeros, and then plug each value into the inequality to see if you get a true inequality statement, which means that region is included in your solution, or a false inequality statement, which means that that region is not included in your solution. Okay, so for example 4, we've got x squared plus x is less than or equal to 6. So the first thing we need to do is subtract that 6 over, and you'll get x squared plus x minus 6 less than or equal to 0. Then we're going to factor and mark the zeros on the number line. X squared plus x minus 6 factors to be x plus 3 times x minus 2. So x plus 3, when we set that equal to 0, gives us a 0 at x equals negative 3, and x minus 2 gives us a 0 at x equals 2. So we mark those on our number line with a closed dot because of the less than or equal to. And then we're going to pick representatives from each of the 3 regions that are created. There's a region that's less than negative 3, the region between negative 3 and 2, and the region that is greater than 2. So good representatives, a good representative of the region less than negative 3 is going to be negative 5. I could have chosen negative 4, negative 6, negative 12. As long as it's less than negative 3, I could have chosen it. Between negative 3 and 2, I'm going to choose 0 because it's just so easy to work with. And then greater than 2, I went ahead and picked 5. Then I just plug it into my inequality statement. Now you can go back to the x squared plus x minus 6 less than or equal to 0 if you want. I think the factored form is a lot easier. So that's what I did. Negative 5 plus 3 gives me negative 2. Negative 5 minus 2 is negative 7. Negative 2 times negative 7 is 14. 14 less than or equal to 0 is a false statement. So that will not be part of my solution. I plug in 0 and I get 0 plus 3 is 3. 0 minus 2 is negative 2. 3 times negative 2 is negative 6, which is less than or equal to 0. So yay, that's a true statement. So that region in between is going to be part of my solution. So I try 5. 5 plus 3 is 8. 5 minus 2 is 3. 8 times 3 is 24. Less than or equal to 0. Well, that's a false statement, so that will not be part of my solution either. So the only region that's in my solution is the region between negative 3 and 2. So the solution of the inequality is negative 3 less than or equal to x less than or equal to 2. And then I wanted to shade that in on my number line, so I shade in the region between negative 3 and 2. Our last example, example 5, we're going to solve x squared minus 2x greater than 15 algebraically. And so we're going to write it in standard form. So x squared minus 2x minus 15 is greater than 0. We're going to factor x plus 3 times x minus 5 is greater than 0. And so our two zeros, x plus 3 equals 0 is going to give me x equals negative 3. X minus 5 equals 0 is going to give me x equals 5. So I'm going to put those on the number line. And so there's negative 3 with an open circle. Here's 5 with an open circle. And I want to pick representatives. I'm showing them with an arrow this time. I'm going to pick negative 4. I'm going to go with 1 just to show you you don't have to go with 0. And I'm going to go with 6. So we're going to test x equals negative 4, x equals 1, and x equals 6. So negative 4 minus 5 times negative 4 plus 3, that gives you negative 9 times negative 1. Well, that is 9, and so that is greater than 0, so that's a true statement. So that's why we've got this part colored in here, because that is part of my solution. X equals 1. 1 minus 5 is negative 4. 1 plus 3 is 4. Negative 4 times 4 is negative 16. Negative 16 is not greater than 0, so that gives me a false statement. So that middle region is not part of my solution. Finally, I test x equals 6. 6 minus 5 is 1. 6 plus 3 is 9. 1 times 9 is 9, which is greater than 0, so that's true. So this arrow to the right, yay, that's already colored in for us. That's great. That's part of our solution. So there's two pieces to our solution. The solution is x less than negative 3, this part over here, or x greater than 5, this part over here. Okay, guys, that's it for lesson 4.9. Again, if you're struggling with those graphing those parabolas, please go back and look at the beginning of the chapter, especially 4.1. You've got to be able to graph a parabola in whatever form I give it to you, but certainly if it's in standard form. So you need to go back and look at that. You need to do the problems to solve on your own, and you need to come to class ready to check those problems to solve on your own and to get started on your rounds. I will see you in class next time. Have a good day.